There are many situations in autonomous robotics that require planning and motion to perform a specific task, rather than just moving between 2 points. Examples include the motion to open a door or to perform a complex weld. These types of problems require a different approach to that typically used for high degree of freedom robotic systems, where motion planning is typically performed in configuration space. An alternative is to perform motion planning in task space, which is defined by the task being performed. Consider this robot that is tasked with drawing a path through this maze. It makes more sense to create a space based around the parameters that suit this task, rather than trying to plan in configuration space. A phenomenon in task space is that often the task space dimensions will align with the manipulator bodies in such a way that they become decoupled. This welding robot, for example, can change rail position or configuration without the tool pose changing. We have developed an algorithm that exploits this to optimize a T-space motion planning problem. We call this task space motion planning decomposition. Here we have a 4 degree of freedom sky robot that has the task of drawing a path through a maze. In this problem we describe our task space as xy, the 2-dimensional coordinate in the maze, rz, the rotation of the pen, and configuration, whether the robot has a right or left-hand configuration. The first part of our algorithm samples T-space parameters and identifies manipulator bodies that remain stationary. Moving through the T-space parameters, we start with x and notice that the pose of all bodies change when the x parameter is changed. The same occurs with the y parameter. With rz, we notice that the pen pose changes, but only around its axis of symmetry, so we regard this as not changing. Finally, with configuration, we notice that the pen and the pen mount are stationary. This results in the dependency matrix, a Boolean matrix of coupled bodies and T-space parameters. The second stage is to sort the T-space parameters, and finally we allocate bodies to parameters when there are no longer any dependent parameters remaining. In this case, the base is not dependent on any parameter and can be allocated first. The pen can be allocated once the x and y parameters are set, the pen mount and joint 4 once rz is set, and joint 1, 2 and 3 once the configuration is set. We have decomposed the original 4 degree of freedom T-space problem into 3 lower complexity problems. The first is to solve the pen with parameters x, y through the maze. Next we solve the mount and joint 4 with rz. Finally, we determine the configuration. Our results show significant planning improvements. For the maze scenario, we found that the decomposition created by our algorithm led to an 80% reduction in planning time over the original T-space problem. We also applied this to a 7 degree of freedom welding problem, where planning was performed up to 3.5 times faster. We believe our method is a practical way to improve planning performance for many common task planning problems.